Okay, good evening everyone. My name is Khalid Alsadhan. I am an undergraduate senior at the George Washington University studying civil and environmental engineering. For the fall of 2017, I will be your teaching assistant for Structural Theory 1 under the supervision of Professor Badi. Now, you should be watching this video after you have just finished your hand calculations for whatever problem you're doing. For this video, let's say you have finished the hand calculations of this problem and you want to use STAAD.Pro to check it. Now, let me first caution you that every homework assignment you guys get, you should always do it by hand first and then check it by the program, not the other way around. Otherwise, you'll fall into this trap where you'll rely on programs for the rest of your life. And as a result of that, you won't become a conscientious engineer. Instead, you'll just be just a robot, just inputting data and not really being an engineer. With that being said, this is our problem statement that we want to solve. And in this first part of the video, I would like to show you guys how to create the beam and how to assign the material for that beam. In the second video, I will show you how to assign the supports of the beam and how to assign the loads to this beam. And finally, in the third video, I will show you guys how to view your results, like your reactionary forces, your shear force diagram, and most importantly, your bending moment diagram. Now, I am currently in Tompkins 4th floor recording this video, so this is what you guys should be seeing when you guys do your problems. You should type in STAAD.Pro in the search bar, you hit OK, and you're presented with a screen like this. Now, on the top left of your screen, you see something called Project Tasks. If you want to start a new project, you click here, or if you want to open up a new project, you can click here. Otherwise, your most recent files will show up here. For example, recitation problem 1. But most importantly, I want you guys to make sure you guys have your license configuration correct. Now, STAAD.Pro offers different design codes based on the region you're in. So if you're in the United Arab Emirates, you would most likely click Middle Eastern design codes. If you're in Japan, you have your Japanese design codes, etc. But because we're in the United States, we will make sure our box for US Design Code Standard is checked. Onward, we can click on New Project. Once you click on New Project, you're presented with a box like this. You have 4 choices to pick from. STAAD.Pro gives the convenience of giving you a brief description of what each of these options are. So, a space structure, which is a 3-dimensional frame structure with loads applied in any plane, is most general. For this class, all our problems are 2-dimensional, whether it's a continuous beam or a determinate truss. So, for that reason, we will click plane. And as you can see here, a plane structure is bound by global XY coordinate system with loads in the same plane. After that, we go to our problem statement and we check the dimensions. Our dimensions are in foot, and our loading dimensions are in kips. With that being said, we make sure our length units is in foot, our force units is in kilopounds, or kips. And now let's name this problem. Let's say recitation problem 1, session 2. This is important. In your location, since each and every one of you are C students, you all should be blessed with a Titan drive where you can save all your problems. So mine is located conveniently at the bottom, so I just click OK, and basically this represents your Titan drive. Okay, so all information here is completed. We can click Next. Now, because our problem is a continuous beam, it would be most sensical to click Add Beam. You can ignore the rest of the options until later. So now we click finish. Once you hit finish, you're presented with this screen, and now you are ready to construct your beam. Okay? First and foremost, I like to work in the two-dimensional plane. As you can see here, we are in the three-dimensional view. I don't like that. So, to fix that, I go up to this button over here, which says View from the positive z-axis. So I click it, and I'm now in the 2D window. Secondly, I don't like using this construction grid because it's very arbitrary and there's a much cleaner way and a simpler way to do it. So, if I want to get rid of this, I go to my snap node/beam box and I click close. Now I have a blank canvas ready to construct my beam. The first and most important thing in constructing a beam is to make sure you have your nodes set up correctly. Now, a node is basically a point on the beam where something is happening. So, for example, let's look at our problem here. Where would our nodes be? We have nodes A, nodes B, node C. And at each node we have something happening. We have a reactionary force at node B, at node A, and it's also the start of our distributed load. At node B, we have a 10 kib concentrated load. At node C, it's the end of our distributed load, and we have a roller support. So with that being said, we have 1, 2, 3 nodes. If I want to start my origin at node A, I will say that this is at x and y coordinate 0, 0. So I go to my coordinate system here, 0, 0, 0. So this is node A. If I want to go to node B, it is 7 feet from node A. So this is node A. Now I hit 7 feet. It's still in the same y direction and it's in the same z direction. So now I have, this is node A, and it's always and it's 7 feet away from node B. Okay, one important thing is everything that you define from your nodes is going to always be in relation to your first node. So for example, since node B is 7 feet away from node A, node C would be 10 feet away from node A. So we would go here, we'd say 10 feet, and we have our beam. We have our nodes, sorry. Now, if I want to assign my beams to these nodes, it is simple. I go up to this icon over here that says Add Beams. I click it, and I click on node A. I attach it to the second node, and then from the second node, I attach it to the third node. And now I have my beam. If you want to display your node numbers or your node points, you can right click, you can go to labels, and you have this box called nodes. Let's say we want to show our node numbers. I can hit nodes numbers, I can click apply. Once I hit apply, I have my node numbers 1, 2, and 3 for A, B, and C. And I hit OK. Now, we have created our beam system and we have assigned our nodes. Let's assign our material. So, if we go to General and go to Property, we can assign our material for this beam. Now, what is our material? Well, it is steel. Well, what kind of steel? W413. Okay. We go to Properties Whole Structure box. We go to Section Database, and a box should be opening, which is this. And W, you can see here, we have our American, we have steel, we have W shape, and we have our W4 by 13. We make sure that is clicked, we make sure it is steel, and then we hit Add. When we click Add, we have it in our little toolbox over here. So when I click, I make sure, oh, and also you'll have these autosaves, which is a good thing. So we click on our W413 steel, and we go down to this assignment method. Now in this assignment method, we always want to make sure we're on use cursor to assign. Basically, our cursor will click on the beam and we can assign it. So if I hover my cursor over here, it will assign it to there, and I click on it, it will assign to all the beams. Okay? So I click on that, I click assign. And now it says assigning, meaning that if I go to my screen over here, I will have this symbol, which means that it's assigned. So I click assign here, and I click assign here. Okay? And now I click close. If you want to see your material, you can always go to labels, you go to properties, you can go to sections, apply, hit close, and you can see your materials here. This concludes the end of part 1. In part 2, I will show you how to create the supports and how to create the loads for this beam. Thank you very much, and good luck.